In this video, I am going to be talking about multi-threading with future objects and package task object. A package task is a class for wrapping any callable function, the function that can be called. You can wrap into a package task object, and through that object you can use that function execution. In this method of using package task, a task is to be associated with this object and object when it is created. When you create an object of package task, you associate a function to it. Then you would invoke function call or invoke the task through that object. If the task is designed to receive parameters, you will pass the parameters when into this invocation of the function through package task object. A package task object invocation actually invokes synchronous something called synchronous execution of the task. It initiates asynchronous execution of the task, which means that the synchronization that is necessary when using a thread class objects is not necessary in this case. Again, one more time, a package task object initiates asynchronous execution. Therefore, synchronization is not necessary. That means you don't need to synchronize the child thread back to the main thread. But sometimes this package task invocation can be associated with a thread object. In that case, for the sake of the thread object, because you are using thread object, you need to synchronize it back. Let us get right into coding. In this coding, again I am going to create a task, a function as a task, and it is going to compute average of the array elements. It is to receive an array. Let me name it average. The first element of address of the first element of the array is going to be received in this parameter, and number of elements in the array is going to be received in this parameter, and it would compute the average value in the loop I plus plus, and it should return average. The return type is double. So it returns the average. In the case of package tasks, what happens is the return value is actually written into the shared state. It is written into the shared state, and the future object that is associated with package tasks object is going to be used to get access to the data that is written in the shared state. So this is the task we have. We need to create a data. Of 500,006. This is the size of the array. My array is going to be this one, and I want to use STL algorithm to populate this array with random numbers. So this function receives the iterator or pointed to the first element in the sequence of elements you want to work with, and the last element address after the last element. And if I want to write data into it, I want to receive this as a reference, so that the changes that are made within this function are actually that are the changes that are made in the actual elements of this array. And x is going to be set to random number in the range 0 to 100. Now to use this for each function, we need to include its library. So the library to include here is algorithm. Now with this we should be able to use it, and if I want to see the data, first 10 elements or last elements in this array, then I can use another for each. Zero, 10, and I receive integer type data. At this time I don't need to receive this as the reference, because I am not making changes to it, and I use a cout object to display data on the output stream and separated by comma. Right now I think this should be okay. Let me just ignore this for a moment, and let me also display the last 10 elements. I'm going to compile this code and see whether it actually gets executed or not. Then I will continue from there. So G++ or warnings 23 output. There is one problem. std defined but not used. Oh, I think there was a problem with I think at least two things. I need to, there's a mismatch of the types, size t, and there's one single column is a problem here. Now these are the elements that are displayed. I actually didn't put the new line character in between these two statements, therefore they are displayed in the same line. I should have put new line character followed by some text for formatting, and again new line character. So new line character. So this should display the put out the output in a better way. I mean, more appealing to our eyes. So now first 10 elements, last 10 elements displayed. With this I'm going to continue with demonstrating how to use package tasks to compute the average, or how to run this task in the package through the package task object, and how to use future object to get access to the average value that is written by this tags, this function. For that, I need to create a package tags object. First, throw only one asynchronous tags. This is a package tags class which is available through the library called future. Future library gives you access to this object, and inside this object you need to specify the type of the function you want to call as a tags. So type of the function, return type double, and parenthesis, and the types of the parameters separated by comma. That is the type of the function. So we're going to have double and constant integer pointer and size t. This is the type of the function we want to associate with a package tags object, and we give a name to this object pt, and we set this to that particular tags average, name of the function. With this we have created a package tags object, and with this object pt there is a future object associated. So let us have a future object as well. It is going to be for double type, because double is the type of the data that is going to be written into the shared state, that is written by the function pt dot so this is I need to give the name for the future object. Let's say if equals to future object name of future object s and p2 dot get future. So this will actually give the return the future object, which is copied associated to f, and we can use this f to access the data that is written by this function, which is actually essentially written in the shared state that you can access by using future object. Now you want to execute tags by just executing pt object pt. This is the way of executing, setting this asynchronous tags in motion. So this is the way, and since the tags actually receives array and size of the array, then you need to pass the array. The name of the array we want to pass is my ARR, and size is going to be SIJD. So this is the way we execute this package tags object, and to get access to the data that is written by this the function, let's give the name avg equals to, we use future object and call function get. Right, this will return the computed average value, and I want to actually write this average value. Right, so this should execute. Let me see if there are problems. I will come back and try to solve those. Save and execute it. Now the average value computed is 49.4921. That was actually computed by a single thread, single package tags execution. Now if I want to perform the same thing by using 4 package tags executions for for the sub arrays, 1/4 of size, first 1/4, second 1/4, third 1/4, and fourth 1/4. For that, just look into this this code structure. You need to have 4 package tags objects, you need to have 4 feature objects, you need to have 4 invocation, and you need to have 4 individual average to be received, and you need to use those 4 received average values to compute the average of the entire array. So let me copy this entire thing and paste downwards, and in this case not only one, it's going to be 4 asynchronous tags. Right, so now let us create 4 package tags objects with the name pt1, pt2, pt3, pt4. Let's have 4 future objects with name f1 through pt1, f2, pt2, f3, pt3, f4, pt4, and 4 invocation pt1, pt2, pt3, pt4. But the array I'm going to pass in individual invocation is going to be first 1/4 size, second 1/4 size. So let me compute the size of the smaller array. Size t equals to size sub array equals to size divided by 4, and use that as size beginning from the first element up to this this number. Right, this is going to be this is size sub, size sub. In the next I want to pass the element at the index size sub, but I want to pass address of that element, and again the total number of elements it will work with is going to be size sub again, and here 2 times size sub address of that particular element, and number of elements it will work with is going to be same. In this case 3 times size sub address of it, and it will work with not size sub, because if we use size sub it will leave some of the elements away, particularly in this case maybe at least 2 or 3 elements will be left away from the computation. So you need to include all the elements, so all the remaining elements should be included, and the way of doing this is just subtract the 3 times size sub from the size. This is the size you want to pass. So this will set 4 tags, asynchronous tags in execution, and each task will actually compute the average of the each subdivision of the array. In the case in the first case it is going to be first 1/4 of the elements, and in the second case it will compute average of second 1/4 of the element. In the third case it will compute average of the third 1/4 elements, and in the fourth execution it will compute the remaining elements, average of remaining elements. Now get function, you need to get data for all 4 cases. Average 1 from f1, average 2 from f2, average 3 from f3, average 4 from f4, and I want to just to distinguish it from the previous display. At this place I want to just put some text here for PTs, package tags, and the thing I want to place here is going to be something divided by size, right? So in something it will be the summation of entire all the elements of the entire array. The way you want to compute is going to be average 1, average of the first sub array times number of elements in the first subarray, which is size sub, plus average of the second subarray plus 3 plus 4. In this case the size is not sub, size sub is it is size minus 3 times sub. So this is the output. This is the expression that you can use to compute the overall average of the entire array. So let me try to compile it. Compile and link and execute. Now you can see the average computed using single package task execution and 4 different package task execution is same. It's precisely same, 4921 4921. Okay. Next, I'm going to demonstrate another aspect of the use of package tasks using the same code. It's also possible that you can execute this package tasks object with a thread, right? So it's also possible, instead of executing it directly, it's also possible that you can create a thread. For this you need to use the thread class, you need to have library included on the top. Now T, then for this case you need to pass package tasks object followed by parameters. Right, so this is the way you pass it. But there is one problem here. When you pass this package tasks, because you know this actually this thread removes R value reference, so you need to pass actually R value reference here. If you pass directly, this package task is not allowed to be copied. Copy is deleted in this case, so you need to move. So you move it into there so that that task is no longer associated with this identifier in this place. And you cannot do this now. And you can get using this approach, but you need to do additional step here, which is synchronization. If you use a thread object, you need to synchronize, join. Right, so I have made this change only in the case where we have used only one task. I want to make sure that it works, then I will show you how to make changes in this in the later case. So let me compile this and make sure that it works without problem. Successful. Yeah, it is working. Average 49.4921 and 49.4921. So we can make change to the later parts where we have 4 individual package tags. So in this case you're going to have 4 different thread object. T1, you pass first package tags object by moving you move in the package tags object into it, T1, and let me move this down after we get future object here at this place. So and pass everything I want to I mean the parameter passing is going to be same as what we passed here, right? And similarly I want to have another thread T2 PT2, and we pass this parameter to it, this arguments to it. T3, and you pass these things into it. So we have these 4 threads which are actually setting this package tags into execution, so I wouldn't need this manual execution in this case. And we actually want to synchronize T1.join right. This is synchronization step, this is spawning step, creating new threads, and everything will be same. Compilation and linking followed by execution. Now you can see the output is exactly same, 49.4921, 49.4921. This is the end of this video. Thank you for watching.